Hello, this is the third video for section 7.1 and 7.3. We are going to have 3 more problems to finish this lesson. Okay, let's read through this. On a construction site, a winch is used to wind cable onto the drum of the winch. For the first layer of cable, the line pull P of the winch is related to the diameter D of the drum by this formula, P equals K divided by D. And it's saying where K is the constant. If P equals 5,400 pounds and D is 4 inches, find the value of the constant K in foot-pounds. All right, so D is in inches, and that means we need it in feet. So 4 out of 12, right, 4 inches out of 12 inches is 1/3 of a foot. Okay, because we need to have this in feet for this formula. Because if you notice up here, it says, it says right here, convert D to feet first. And our answer's in foot-pounds, right? So we need that foot in there. Okay, so we're going to put the numbers in, right? 5,400 for P. And K is our constant, that's the part we're looking for, and 1/3 is in our denominator. So that's kind of a little bit of a different looking formula. To solve for K, we need to get rid of that denominator so we can multiply by it on both sides. All right, so that's going to cancel that out. And 1/3 of 5,400 is 1,800. And that would be foot-pounds. And so that is what K is equal to in this case. The constant K would be 1,800. Automotive trades. For modern automobile engines, horsepower is defined as the horsepower is equal to torque, that's in foot-pounds, times the engine speed, and that's in RPMs, right, revolutions per minute, divided by 5,252. If an engine has a peak horsepower of 285 horsepower at 480 RPMs, okay, so it's telling us that's our horsepower, right? So that goes in for the HP. This is our RPM, so that's our engine speed. What is the torque of the engine, right? What is the torque of the engine at this speed? So we're looking for the torque this time, which, you know, it makes it a little bit tricky, but not too bad. All right, so horsepower, 285, goes in for HP. We're looking for the torque, and I'm going to call that T. We multiply that times the engine speed, which was 4,800. And then the number 5,252 is what we're dividing by, and that's just given in the formula. So to solve this, we have to get rid of our denominator, and we can do that by multiplying both sides, right? The opposite of division is multiplication, so we multiply by that on both sides. And then we multiply that out. It is, let me write this out and then I'll say it. So that is 1,496,820. And that equals, right, this cancels out, 4,800 T. So I'm going to write it that way because usually we put the variable to the right of any of the numbers there. Now, to solve, we divide by 4,800. And T is 311.8. We're going to round that to a whole number as it told us to do here. So 312 pounds times feet. So that it told us it was pounds times feet in the problem, the torque. So that's how we would write that for the torque. All right, last question. Metalworking. The surface speed S in feet per minute of a rotating cylindrical object is S equals pi times d times n. D is the diameter, n is the speed of rotation, divided by 12. And I said that down below. So if an 8-inch grinder must have a surface speed of 6,000 feet per minute, what should the speed of rotation be? We're going to use 3.14 for pi and round to the nearest 100 RPMs. Okay. So we've got the S is in feet per minute. And so here's our S, the 6,000. Right, this is S. So we're going to put 6,000 in for that. 3.14 for pi. And then it tells us that our diameter is going to be 8 inches. And then we're looking for N. 12 is part of the formula. Okay, so we multiply 3.14 times 8, which is 25. Let me write this in here. All right, 25.12 N divided by 12. You could have multiplied by 12 first or multiplied the 3.14 times 8. Either way is fine. I'm multiplying both sides times 12. And that cancels out my 12 because that happens every time when I multiply. Because really I'm multiplying by 12 over 1. So it just simply cancels out. Okay, so now I'll write this over here. I have 72,000 equals 25.12 N. We divide by this. And then N is approximately 2,866, and it tells us to round to the nearest 100 RPMs. So we're going to round that to the hundreds place, right? So N is about 2,900 RPMs. It sort of looks like an R. Okay, so that is the end of that lesson. Now, I know this is a lot of numbers, a lot of substituting and calculating here, but it is really about being able to solve a formula for whatever part you need to solve it for. And in this case, we did lots of practice. Okay, bye everyone.